Hi, and welcome to chapter 10. This chapter is really split, I think, in two parts. It's not meant to be, but it's about operations management. That's what the chapter is about. So we'll talk a lot about first operations management per se, facilities layout, etc. But the second part really is about quality. And yes, quality is used essentially, mostly in areas of production and operations management, but not exclusively. You'll see that we're using quality everywhere. And so it's really, just remember that it's split in two. So let's get started. Learning outcomes for this chapter. We'll look at why production and operations management is important, both manufacturing and service. We tend to think of these things just for manufacturing, but obviously very important service. And why does that matter? Well, remember, over 3/4 of the entire GDP of the United States is service-based, right? We tend to focus so much on manufacturing, and of course manufacturing is critical, but the majority of the American economy comes from service. We'll look at types of production processes that manufacturers and services use. We'll look at how organizations decide where to put their production facilities, where you're going to build that factory, what choices are made in designing the facility. We'll look at resources planning tasks, inventory management, supply relationship, and how operations managers schedule and control production. And then we'll look into the quality part. Again, how quality management, lean manufacturing help firm improve production and operations management. The role of technology, automation, and trans. I'll focus really mostly on 1 through 6 for this lecture, and we'll let you guys read 7 and 8 on your own, so I can try to keep this under an hour. Let's get going. So first, basic definitions here. Production, creation of products and services. Again, I think we have this weird knee-jerk reaction to think of production as just only applicable for things that are tangible, building a car. But production, of course, also involves services. Definition is what we're turning input, such as natural resources, raw material, human resource, and capital into outputs, which are either products or services. I've used before the example of the huge aluminum rolls. You've seen these semi-trucks on the highway with flatbeds and these big monster rolls of aluminum. And so that would be the input on making a Tesla. And they load the rolls onto these machines, and then the aluminum sheets are pulled out and stamped into a hood or a door, etc. Just a very basic way of looking at it. Operations management manages the production conversion process. So now we're talking about this entire process of going from raw material to whatever the output is. Customer satisfaction is an important part of effective production and operation. I think that's an understatement. It's a critical part. And so we'll see when we get into the quality section, and I'm giving you a taste of it, but when you take management, MGMT 40, Management 40, in that class, I spend more time on it. Operations managers, they manage and supervise the conversion process. Production and operations management involve 3 types of decisions. So the first one is production planning. Second is production control. Third is improving production operations. So, just remember those are the 3 main ones. What I have for you here for the hyperlink is for those of you who are maybe already doing this. Some of you, are already working maybe in warehousing, distribution, or logistics. We have a really great degree at JV College for those of you who are interested, or again, you're already doing it, in supply chain management. It's recognized. A lot of our students are with this degree are getting jobs before they even transfer. So, if you're interested, look at it, and you might find that it's for you. So, moving on now, just to kind of a visual representation of the production process. there it is. You've got your inputs, factors of production, natural resources, raw material, human resources, and of course capital. You've got the conversion process, and then of course the output, either product or service. Nice little visual here for us to grasp this thing. Let's get into production planning. Allows firm to consider the competitive environment and its own strategic goals to find the best production methods. I'm sorry, but I'm going to probably have to use a bunch of Tesla examples only because it's just phenomenal. In terms of capacity, when Elon Musk created the Gigafactory, and now there's several out there, some people thought, why does it have to be so big? Why is he designing a plant where currently he's not even using, I believe, not even 1/3 of the plant in terms of production capacity? So why does it have to be that big? Well, he's going for scalability, obviously. The most expensive part of an electric car is the battery. He had a strategic alliance with Panasonic, and the idea being that if they can ramp up, scale up production, then the per unit cost of the batteries would go down, and they would sell more, and because they sell more, they make more, and because they make more, the per unit cost keeps going down through scalability. So in this case, he's really thinking ahead with production planning by virtue of getting financing for a plant that he's not even optimizing right now. So the 3 phases, the long-term planning, that's why I wanted to give you that Tesla example. It is very much long-term. And Elon Musk, of course, being brilliant, has had several stages in his strategy to have built the company. He started with a little Roadster, which was over $100,000 car, and then, of course, the Model S. So he sold these very big ticket items, and little by little, he's working his way down to the Model 3, which is supposed to be eventually a $20,000 car, eventually. And so that's a very long-term plan from the first Roadster that he created. So long-term planning in terms of production, facilities, layout, etc. Focusing on which goods to produce, the quantity to produce. These are examples I gave you. Medium term, what factory layout to use, where and how to get needed resources and labor issues. So this is where the layout, in fact, is going to be maybe modified. I'll talk more later on about the U-shaped layout. And so, there's some really interesting things out there in terms of layout, not the standard, very beginning to end, one big line layout that we tend to think about. And of course, short term, converting broad goals into specific production plans. Think more, just, boots on the ground, making it happen, more operational. Okay, production process is the way the good or service is created. By the way, when you transfer, you will learn all this in operations management. So this is operations management, and there are lots and lots of tools. You'll use statistics to better understand these processes. In production planning, the first decision involves the type of production process best fits with the company's goal and customer demand. So you'll have 3 types, right? The mass production, manufacturing many identical goods at once. If you're not careful, and if you're in the business of mass production, just think of mass production as have it my way, right? And so in this particular case with mass production, you're the one who's deciding to do it your way. Think Henry Ford Model T. Yes, you can have it in any color as long as it's black, quote. So that's mass production. The problem with mass production is maybe I want to tweak this thing. Maybe I want to modify it. Maybe I don't want it in this particular way. So this is where mass customization comes in. One of the very famous example of a company that's still around and in an industry that's super saturated and products have been commoditized to no end is Dell, right? Dell Computers. And Michael Dell, a while back, the visionary that he is, realized that customizing these production lines was the way to go. And so think about mass customization as, have it your way. So goods are produced using mass production techniques up to a point. And so when you put in your order for a Dell online and you have several choices, let's say for a video card, then the choices as the computer is being built on the fly, your box, your computer has an identifier on the line, and once it gets to the stage of the video card implementation, without wasting any time, the video card that you selected would be slapped into the motherboard. Assuming it's a PC desktop. Customization, production of goods and services at one time according to the needs or wants of individual customers. This is where the example of a job shop comes in. It's a manufacturing firm that produces goods in response to customer order. The example in your in your book is of a silk screening type business, where ordering a bunch of T-shirts with a design that you want, right? Obviously, the company that makes those is just going to use them for you. So again, some examples here from your author. You got the mass production, mass customization, and customization. So, Coca-Cola, boom, mass production, right? Mass customization, there it is, Dell computers, tract homes, golf clubs, and then customization, custom homes, legal services, and haircuts. All right, moving along, converting inputs to outputs. So the two basic processes for converting inputs to outputs are process manufacturing or assembly process. So process manufacturing, you're looking at your basic input, could be any natural resources, raw material, broken down into one or more outputs of product. And so, in this case, the example is bauxite used as the input to make aluminum, the output back to the aluminum example that we were using earlier. The assembly process, just the opposite. The basic input, like natural resources, etc., are either combined to create the output or transformed into the output. So we're talking about making a car, for example. So that's the assembly process, making an airplane, etc. Production timing, continuous versus intermittent process. So continuous process, long production runs that may last days, weeks, etc. Think about the utility company Edison. It doesn't shut down. It's ongoing. There's several shifts, but it's a continuous process. Intermittent, there you go, short production runs, etc. The converting inputs to outputs example again here, again, airlines, there we go, giving you examples of the inputs and the outputs. Grocery stores, there's the input for outcomes, that's there it is. High school, graduate public, you get the idea. All right, now, next part is where are we going to build this factory? Where are we going to put it? So location, location, location. You'll hear these three words together often in marketing. We always say these are the three most important parts of marketing, right? Where do we make it for distribution? So first, what are the factors to consider in terms of location? There's several. Availability of production inputs, accessibility of raw material, parts, equipment, or even labor, skilled labor for what you're trying to do. When we talked about when we covered the global chapter earlier in this class, maybe you'll remember the word agglomeration. And that's the idea that there is a geographical area that is extremely rich in maybe support, logistics, distribution, labor for a particular industry. Most common example of that is Silicon Valley in California, where if you're going to start a computer company or designing the next big app, etc., this is where all the resources are, right? And so that's an example of that. Marketing factor is assessment of how location will affect the ability to serve customers. Maybe the cheapest location is not a great idea for you because you'll be too far from your base. And so maybe that's a problem for you. The environment, assessment of manufacturing environment, availability of resources, accessibility to suppliers, and transportation. Maybe you're going down the boondocks, and if you do that, you're going to have to build your own roads, your own bridges, who knows? So again, making sure that the environment is set for that. I always think about the maquiladoras in Mexico, right? In the 90s, manufacturing environment at the border towns south of the border in Mexico, where a lot of the stuff that we were buying, and still do, by the way, are made in the maquilas. The local incentives, tax breaks, etc. When Elon Musk was, put the word out that he was looking for a location for his gigafactory, he had several, bids, really literally bids from states, and he was, again, he was pretty clever when he floated the states that he was interested in, and very strategic about them for various reasons. One of them is that he was also trying to court states that did not allow the Tesla model dealership, stores. Because it is not a dealership in their states. Just to kind of explain real quick, Tesla sells cars to the public directly. There's no middleman, right? Which is an exception in the auto industry because typically you go to a dealership, which, by the way, of course, jacks up the price of the car because the dealer takes a cut. And so in this particular case, Arizona ended up winning as the location for Tesla Gigafactory. And what you see here: tax breaks, financial assistance, exemptions, etc. So those are some things that worked in the favor of Arizona, and where Arizona won the bid, if you will, in terms of having Tesla pick that location to build its Gigafactory, which I believe is one of the biggest car manufacturer in the world. I believe Volkswagen, I think, still wins, I guess, in terms of footprint, but it goes back and forth. International location consideration, there's the global factor there. You're looking at labor cost. Obviously, if you can go to a country that's got a cheaper labor, wage, that's fantastic. Fewer regulations. And this is where ethics comes in, by the way. Why are you interested in less regulation? Is it so you can pollute more? And so, very important. And proximity to markets, obviously. Mercedes-Benz makes its SUVs in Tuscaloosa, Alabama, right? So most, I can't remember what they're called, but most of the SUVs that Mercedes-Benz makes is in the market that it sells them, right, in the US. All right, so let's see. Designing the facility where it gets interesting. The way that the footprint, the layout of the facility is going to be really critical for lots of reasons. Efficiency, quality, and flexibility even. All are going to be things that you're going to, and of course cost, that you're going to put into this. So the process layout, all welders stand there. So in this case, it's manufacturer of custom machinery would use a process layout. The product layout, moving down the line, so think about cars, appliances, etc. Fixed position layout, on-site services like house cleaning, etc. I mean, that's it. And cellular manufacturing combines some aspect of both product and fixed position layout. Here's a visual for you from the book. So there you go at the top there, left, job X, job Y. You can see the process layout, production of kitchen cabinets, and how job X and job Y would be a little bit different in terms of the production operations. Below that, bottom left, the product assembly layout, assembly of flat screen TVs. You can see how in this particular case the layout is. And of course the fixed, someone here, they're building a stadium of some sort. And so you can see how everybody, of course, is working in that fixed position. Pretty straightforward stuff. All right, now let's group everything we've talked about together to talk about resource planning. And so begins by specifying which raw material and components will be required and when the product, when to produce, the finished goods. So make or buy decision is a big one. Again, sorry, I go back to the global business, but that's always like a huge decision. Firms must decide whether to make their own production material or buy them from outside sources. And so outsourcing is that, right? You purchase from an outside source instead of making them internally. maybe let me just give you an example that I always find fascinating, which is a German transmission company called Getrag, although I think they changed their name recently. Let's see, there we go. And so Getrag is perfect. They changed their name to Magna PT, right? World's largest supplier of transmission for cars. So you're driving whatever car you're driving. It could be a Ford or BMW, doesn't matter. Very likely that your car has a Magna PT transmission. I mean, the list is huge, right? And what's impressive about this is not even just the list, but also country of origin where they manufacture these transmissions, right? And so you could see that this there's a reason they're the biggest transmission company in the world, and that's of course because of their footprint, among other things. Why would you want to make your own transmission is the question, right? If you make your own transmission, several things are going to happen. Number one, we can say your level of expertise is not the same as Magna level of expertise. Why? Because they're a specialist. How do we know? They're number one in the world. And so number one, you can't claim specialization. You can't claim that you're really good at this thing because someone else is better than you. So that's the first thing. The second thing is cost. Because you do not have scalability, you're going to make it just for yourself. And the number of transmissions you manufacture is going to dwarf in comparison to transmissions made by Magna. And so in this particular case, your cost is going to be tremendous. And the last, of course, is quality. And it's not going to be possible for your quality to be at the same level as Magna, again, because of specialization, scalability and specialization. And so if you think about, the question becomes, am I going to add value if I make my own transmissions? Would that add value? And value to whom? The customer, right? Is the customer better off if I make my own transmission, or are they better off if I just buy one from Magna? And of course the answer is Magna. Most people don't care. They get in the car, they turn it on, they just want the thing to work. And so if you're able to do that with great quality product and lower cost, you win. And if the outsourcing is the name of the game, that's it. And so, just again, I know hopefully you're able to tie this in with what we've talked about with Global so far. All right, moving along with inventory management, not just parts. So inventory, supply goods, company holds, easy enough, right? So if you have, 20,000 square foot location, and you're manufacturing something or you're selling a product, doesn't matter. And you need inventory, right? And so the question becomes like, well, how much of your footprint is going to be allocated to having these extra parts sitting around, right? So 20,000 square feet, let's see, 5,000 square feet is what you're going to have sitting around. You're paying for that space. I want you to think about that square footage. You're paying on your lease, triple net, whatever you have, every month. You're paying a lot of money for that square footage just to have inventory. And even worse, you're paying for inventory to not be available for sale, but just to sit there so you can have access to it when you need it later on. You see where I'm going with this. Inventory is a killer. Inventory is bad. You don't want inventory. So inventory management is in deciding how much of inventory you should have on hand, what you're going to order, how much of it, receiving, storing, tracking, everything. Most companies keep a perpetual inventory, continuous updated list of inventory level. The cool thing about this is now, of course, computers do that for us, right? Great point of sale systems that retailers even have that do that. So let's go with the computerized resource planning. Speaking of, many manufacturing companies have adopted computerized systems. I'm not going to get into too much detail of that, but especially for those of you who are in industry or learning or moving toward getting the degree, you'll learn a lot more about that down the line. But you have your MRP uses a master schedule to ensure that the material, labor, equipment needed are right place, right amount, right time. And then you're getting into the MRP2, which came out in the 80s, expanded on the MRP to integrate data from many departments, finance, etc., so that you can truly optimize your resource planning and manufacturing. And then you're getting into whereas MRP and MRP and MRP2 are internal, ERP is going a step further by incorporating information about firms, suppliers, and customers into a flow of data. So now you're really, truly optimizing your production by integrating your suppliers, vendors, distributors within your setup, and where you're connected with them. They're part of the solution. You actually meet with them. They make recommendations, but you can see you have a better view of what's going on because of that partnership. There's the biggest supplier distributor of electronics in the world. You probably never heard of because they're very much behind the scenes, but they're very impressive. Ingram Micro is the name of the company, and when they're just so impressive with what they do. If you think about it, that this is a company that reinvented itself actually during the last recession. Why? Well, sales were going down, and these guys ended up buying a bunch of other companies and became this unbelievable powerhouse, right? 64 countries, 6 continents. This company is just absolutely astounding, right? The revenue, how much square footage they have. Look at that one. Mobile devices. One out of every 2 devices in the US, they handle. It goes through them. When you buy that iPhone, brand new model that you ordered online and you're going to get in the mail, it is not coming from Apple. It's coming from Ingram Micro. My kids' video games, same thing. It's all coming from Ingram Micro. And cloud, by the way, they're also really getting dominance in cloud. So anyway, that's kind of an example of that. Supply chain can be thought of the entire sequence of securing the inputs, production, etc. If any link are weak, then the endpoint will be dissatisfied. So that thing has to just really be, again, I use the word optimized, right? Things working well in concert for the benefit of the adding value to the customer. That's always your endpoint. Your supply chain management is focused on smoothing transition along the supply chain. Now, this is where we're getting into that statistical part I was telling you about earlier when you take operations management after you transfer, where we are looking at scheduling, etc. So Gantt chart, all that stuff. Operations manager prepares timetable showing the most efficient sequence in production. By the way, sometimes the stuff is completely counterintuitive. What you think is logical and sequential, there may be a more optimized way that you could not have thought of were it not for a computer that did the work for you. For those of you who took management with me, you already know the Gantt charts, right? Henry Gantt famously came up with a bar graph. I'll show you on the next slide. You probably use some variation of that at work, some of you. The CPM, this is the stuff you learn in operations management. It's a beautiful, brilliant way to just optimize ways that the activities required to complete the project, relationship with the activities, and the order in which a critical path method, stepping stone, all that stuff you'll learn in operations. And the program evaluation review technique, the PERT, differs from CPM. The PERT assigns 3 time estimates for each activity that allow managers to anticipate delays. And so there's an optimistic time for completion, a probable time, and a pessimistic time. Again, you will learn way more about this and in a quantified manner. This is why statistics and business statistics are a requirement in business so that when you take a class like operations management, you can appreciate it. Hopefully I'm not scaring you from it. It's just part of the deal. Let's see. So Gantt chart, that's it. Here we go. Scheduling, designing. So I can't remember what this example is, but sometimes they use the example of building a house, etc. But basically, if you look at the dates at the very top, scheduling must be happening between these two timelines, right? And the completed work is those rectangles here. The review date, there it is, right there. There's going to be only one. And it's kind of letting you know when you look at schedule to start activity with a symbol here on the left. So there we go, schedule to start and schedule to end right there. So what happens is that for example, ordering cannot start until scheduling has been completed and designing has begun and maybe about halfway. So that's kind of how that thing's going to work, right? So you get the idea. That's a typical Gantt chart. CPM for building a house, there's one right there. So you got your critical path over here in pink and your activities in days. So it's kind of letting you know if you follow first the critical path and you go from start to house is ready and clean, and then your activities in days are the things that are going to be required for you to complete your critical path. So example, frame complete. Going from that to cabinets and wall complete, you have 15 days here, and within those 15 days, you're giving yourself 5 days from frame completion to electrical wiring, 8 days from plumbing to complete, which is less than 15 days, and so hopefully that's all you're doing here for that. But you get the idea. All right, now we're done with that, and let's get to one of my favorite chapters, my favorite part of the whole class, which is quality. Every time you take a class, whatever the class is, you have a professor, that is going to really focus on something. Nicole DeRose teaches biology, and she just loves that Krebs cycle, and she will go on and on and on for months and months about the Krebs cycle because she's so passionate about it. I think she has an entire 2,000 point exam just on the Krebs cycle. Anyway, maybe I'm exaggerating, but you get the idea. Everybody has a thing, right? Professor Karp loves lots of things in law, but antitrust, his level of expertise. So everybody's got a thing, right? So quality. Let me ask you this. When you think about quality, a lot of people think about, quality, my microwave or my fridge, I want it to be good, whatever. But would you eat at a restaurant that earned a low grade from the health department? So you know how this works. Here in California, this is taken from the County of LA Public Health website. And you're very familiar with the letter grades, right? A, B, C. By the way, is there a D? Is there an F? Well, interestingly enough, there's no letters when you go below C. So once you below C, you'll see it on the left over here. Once you get, there's no D, you will just have a score. So if you ever see numbers instead of letters, you're in trouble. Maybe rethink going there. And so, I know some students are comfortable going to a restaurant that has a B, and some are like, no, it's got to have an A. I don't care. And most students will just usually say, no to C. I mean, C is really going to hurt business. And I mean, forget it. When there's a number here, then, nobody wants to even try that. And so you get the idea. So my question to you is, how many of you go to these, and how many of you will not go to a B or a C or 50%? And why will you not go? You have a reason, right? You're afraid you're going to get sick, food poisoning, something. And so, that's just kind of my way of introducing the idea of quality, right? I mean, seriously, food handling practices. How hard is it for that to happen? Most restaurants don't have a problem getting an A. How low does it be? Does it have to be for you to screw up that badly? Is it because you didn't train someone else? Well, usually what happens in quality is we say no. You can't blame it on someone. You blame it on the system that you created in that restaurant. You did not create the right system. You did not create the right culture. right? And so that's kind of a way for me to introduce that to you, that concept of quality. So now that I've used that for restaurants, and you see those prominent letters here, A, B, C, right? How would you feel about that same ranking existing with hospitals? You've heard horror stories, right? I'm sure some hospitals, or you know someone, or maybe hopefully it didn't happen to you, but or a loved one, but you've heard people going to hospital, lawsuits, litigation, settlements because of some bad thing that happened. And a lot of hospitals are going to talk about what's called human error. Hey, I'm not a robot, I'm not a machine, human error. So my question to you is, do you think that would be a good idea? I mean, we have it for restaurants. Do you think it's a good idea to have that system for hospitals, right? Can you imagine you're driving up the hospital and, you're not in immediate, life or death situation, but you're in great pain, and you pull over and you see a C there. And I don't know if I want to go there, right? Well, I got good news for you. There's a nonprofit organization called Leapfrog in Washington, D.C., and they've been around for a while, I think 20 years now, and they're amazing. And what they've done is they've created, actually, this hospitalsafetygrade.org is their website for the Hospital Safety Grade website. And I just did a screenshot here. This is a .org. New reports find risk of death nearly doubles for patients using hospitals graded D or F. Now, they obviously, the hospitals are not required to put their letter grade in front of their door like restaurants have to. Maybe in the future, it would be fantastic. I think it would really motivate them to improve, right? But look at that. Patients at D and F hospitals face 92% greater risk of avoidable death. And by the way, avoidable death, meaning the other hospitals have found ways to make sure this stuff doesn't happen. And yet, a lot of hospitals getting Ds and Fs still making those mistakes. This is a systemic issue. Again, it's not human error. This is a systems problem. Patients at C hospitals, on average, 88% greater risk. And then at B, 35%. So obviously, I'm sure everybody here is probably now all of a sudden interested in where's the A hospitals, right? And by the way, this is spring 2019, so that's how old that is. Even A hospitals are not totally safe, but researchers found that they're getting safer. And look at that, if all hospitals had an avoidable death rate equivalent to A hospitals, 50,000 lives would have been saved versus 33,000 lives would have been saved by A-level performance in 2016. So these are real numbers. All right, now hopefully this is not going to be too scary for you, but here we are in the in the Inland Empire. So let's do this. Let's go by Rancho Cucamonga. Here we go. California, and let's see what we got in Rancho, around Rancho. So we'll get a radius, but you can see, and I'm not being disparaging. I'm not the one who's coming up with the data, but you can see what hospitals are doing well, and what hospitals are not doing well, right? And so you've got some issues there, and you'll see that they specialize, and maybe some hospitals are doing well in some areas and not in other areas, right? And so let's just click on this first one since it's here with a C, and let's look at their score. So here's what's really cool about this. You can see exactly where they rank low and where they rank high. So MRSA, the good news is they're doing pretty good with MRSA, right? There it is. So this hospital has a score of 0.758, right? You want 0. You want no cases, no problem. Now, the average hospital is at 0.8, and this hospital is at 0.758. So what gives them a good score is their slightly better than the average hospital. By the way, the worst hospital is 3.213. Can you imagine? So that means you're still likely to get MRSA from that hospital, but and if it had a 0, then of course you'll be fine. And then you can see how things kind of change very rapidly here with other types of infection. Infection of the blood, septicemia, is deadly, can be deadly, especially with the elderly. So if the average hospital score is a 0.7, this one is at 0.775, which is why it's ranking there. The worst at 2.6. You get the idea. Some of the stuff is just pretty horrendous, right? Surgical site infection after colon surgery, average hospital is 0.8. This one's at 1. So there's issues, problems with surgery, right? I mean, again, for me, I'd want to know before I make an appointment. Let's see where, am I going in there for a long issue, collapse lung? Okay, let's see what's going on over here. Surgical wounds split open. How are we doing over here? All right, hopefully you have not had lunch yet. Okay, I hope I made my point. My point is that quality really, really matters. When I first started teaching, I would focus on the auto industry because it's fascinating, it's easily measurable, it's, you buy a car and it breaks down or it doesn't, and how likely is it not, etc., etc. But I thought, where are the stakes greater than life? None, right? There's nothing greater than that in terms of stakes. And so this applies to all of us. All right, so now that I've done that as my little intro, let's get into quality. You can probably guess that this is definitely one of my favorite chapters, one of my favorite areas. And when I studied this in college, this is the gentleman who really, really kind of, made an impact on me as a business student. I'll talk about him in a little bit, Dr. W.E. Deming, William Edwards Deming. So first, let's define quality. Goods and services meet customer expectation by providing reliable performance. All right, easy enough. What is quality control? It involves creating quality standards, producing goods that meet them, and measure finished goods and servicing. Basic stuff, right? So let me first kind of tell you a little bit about Deming, who's truly one of the main people responsible for quality as we know it today in the United States. He's not the only. Juran is another one. But Deming gets credit as really having advanced quality on a whole other level. Born in 1900, he was a PhD statistician. We sent him to Japan after World War II to help with the reconstruction effort in Japan by virtue of the post-war census. He was, as a statistician, one of his levels of expertise was census, right? He was a pioneer, in fact, in designing some of the tools for the U.S. Census. More importantly, he worked at Bell Labs during World War II, and he applied some of his statistical methods in creating various military machines that the U.S. used during the war. And by the end of the war, everybody saw that the U.S. had achieved a real superior level of manufacturing when it came to quality with military product. And that's how actually he became very, very famous, among other things. So Edward Deming, American management consultant, first to say that quality control should be a company-wide goal. Now, this is a big deal because it sounds easy enough, but just so you know, before Deming, if you went up to a CEO and you said you want to talk about quality and improving quality, they would say, oh, no, you don't need to talk to me. Go to my operations people. Go to the guy who runs the assembly line and, find out how he's doing it. And that's who you need to talk to. And Deming said, no, you don't understand. You can't do it that way. It's a systems-based philosophy. If someone works on an assembly line and at the end of, his or her shift, you find out there's 20% defects in production. Traditional way was give the person a warning, put them on unpaid leave, punish them, something, right? Which is, by the way, horrible, because what that person is going to do is hide future mistakes that they make because they don't want to be reprimanded and lose money. So think about how the unintended consequence of that policy are really going to backfire on quality even worse. what Deming said is, number one, you got to go for transparency. You got to even celebrate mistakes. And you need to understand how they work, right? You go to a store and, you want to order coffee. You go to a place, you get coffee, and they give you the wrong one. You come back in, you give me the wrong coffee. It's not what I ordered. Oh, I'm sorry. So they try to make you feel better. They give you another coffee. They give you a coupon next time you come back. Here's that one on us. Did they solve the problem? Did they solve the problem? Of course not. The problem would have been to analyze how did that happen in the first place? And can we design a better system? Can we implement some kind of a process, procedure, system internally to ensure that this kind of deviation from the norm does not happen again? And so that's where Deming really just came through with that. So his ideas were largely adopted by the Japanese in the 50s, but largely ignored in the US until the 70s. In fact, he in the 80s is when he became like a god in the United States, because all of a sudden the US, we realized that Japan was making more cars than we were, and the quality was astounding. So we had to play catch up in the 80s, and that's when we learned that he had helped Japan with quality, and we turned him down, actually. So not all of us. General Electric was one of the very early adopters of the Deming method in the 50s and 60s. Deming believed that quality control starts with top management, who must foster a company-wide culture dedicated to producing quality. That little GIF here that you see is a PDCA cycle. It's called PDCA, and it goes on forever, right? Plan, do, check, act. So you plan on the thing you're going to do. I plan on getting an A. I take the quiz. I got a C. I'm sorry. Yeah, you take the quiz, D, and then you check. I got a C. And then you act. What can I do differently? What did I learn from that? Do I need to study differently? Do I need to rethink my priorities? And then you make the modification by modifying your plan, and then you take the next exam. When does this little wheel stop? Never. What's at the center of it? What's that yellow thing here? That's continuous improvement. The PDCA cycle, known as the Deming cycle or the Shewhart cycle, is at the very, very heart of quality, and it never stops. You applying it to you, you don't stop learning. You don't ever think like, I know enough and I don't need to learn. And so what I'll do now here for you is show you a clip.
Deming is different than the other management methods that are out there. The Deming philosophy looks at the long term.
Short-term thinking doesn't allow for variation. It doesn't allow for understanding that it's not next quarter that's important, not even next year, 5 years, 10 years out.
Deming releases potential in people that has been untapped, that resource that most organizations don't realize is there.
He didn't give you a formula. He didn't say do step 1, step 2, step 3 and it'll all work out. He said that everyone's a willing worker. Everyone has a right to enjoy their job. Deming helped us change.
Deming saw that you don't attack complexity with greater complexity. You want to attack complexity with simplicity. He saw things that other people didn't see because he was a scientist.
Science knows a lot of things that we don't take advantage of in the corporate world. And I think that's what Deming was after. He's like, look at the science, look at the knowledge that's out there and apply that in your business.
Most of the other business theories are more or less checklists. This is an all-encompassing philosophy.
Technology is moving at warp speed. We got big data. We got stuff that didn't exist just a few years ago. But our philosophy of management hadn't changed a bit.
So many managers recognize that the tools they have, what they've been taught, the way they've been taught how to manage, does not allow people to be who they are, and it's not very effective.
Dr. Deming said, look, you got to understand the impact of fear on an organization is so huge. The cost is unknown and unknowable.
If attracting talent is important to you, it's important to realize that money only goes a certain distance. Dr. Deming talked about joy in work, and that applies to not just the fellow on the line, but the CEO. It applies to everybody in the organization.
In this time that we're in now, they want to have flexibility. They want to be treated with respect.
Things are so very competitive, and now is the time to help people.
Pick up the paper in the morning. I see different decisions that would be made if people understood the Deming philosophy all over the place.
We need to get more people viewing the world with a different lens because of the problems. The solution is a different way of running your business. Deming's more valid today than ever.
I hope you enjoyed this video, and as you can tell, I'm a big fan. Full disclosure, I did attend the Deming Institute in early 2000. It was a week long, and it was just really fascinating because of the philosophy of Deming that really is at the heart of everything we do today that are best practices when it comes to quality. Now that you understand this, so let's get into the Deming concept of TQM, Total Quality Management, emphasizes the use of quality principles in all aspects of a company's production and operations. It recognizes that all employees involved with bringing a product or service to customers, marketing, purchasing, accounting, etc., contribute to its quality. And it was mind-blowing at the time because people again thought, you know, this quality belongs in production, in operations, and that's it. And so TQM focuses on continuous improvement. I mentioned that before. A commitment to constantly seek better ways of doing things in order to achieve greater efficiency and improve quality. A company-wide team works together to prevent problems and systematically improve key processes instead of troubleshooting problems only as they arise. So that's TQM. Now that we understand that, again, everybody's involved. It starts from the top. In fact, in the 80s, what was fascinating is that many CEOs reached out to Deming. And, you know, he was in his 80s, right? He was born 1900. And he just ran out of patience. And CEOs would, basically, he would interview them instead of them interviewing him. And he felt that if they didn't really, truly seem to understand TQM, meaning that it had to start with them, he would turn them down. There were several CEOs who kind of, would say that, he gave me homework and it took me 6 months to be able to convince him that we are ready to do it your way. He was a very interesting character for sure. So another quality control method is Six Sigma, right? Now I added this TQM on steroids because that's when it came out what a lot of people called it. TQM was really tough. TQM is, a lot of people used to say, imagine like a ginormous plate of pasta and you try to have to eat the whole thing at once. You just can't, eat parts of it or do it in chunks. It's the all or nothing. What Six Sigma did is it streamlined a lot of the processes of TQM, made it more actionable. And so basically Six Sigma, I want you to think of it as TQM, but definitely with great modifications that make it a better program to execute within a company. The opening case of this chapter talked about the whole black belt, green belt thing, and master black belt, and this is how they call the Six Sigma trainers. Many companies became extremely famous because they employed Six Sigma. Probably the most famous of all was General Electric when in its glory days, when the company was doing so well. They credited by the implementation of Six Sigma, which, by the way, I believe was pioneered by Motorola. All right, let's see. The aim is to have every process produce no more than 3.4 defects per million. I mean, think about that. Aren't you glad when you're flying in an airplane that if that airplane has a General Electric engine, motor, that GE uses Six Sigma? Aren't you glad? Because that's 3.4 defective motor for every 1 million motors out there. And by the way, they've gone way past the Six Sigma in many areas, right? So Six Sigma stops at 3.4 defects, but you could go 7, 8 Sigmas. Many companies stop at 2 or 3. Six Sigma focuses on designing products that only have fewer defects, but also satisfy customer needs. So the question is this: why do I have to have so many parts in a product? And maybe you have goals. Maybe the product has 100 parts, and you have a goal in 5 years to bring that down to 80 parts. And that's going to do a lot for you. Number one, less parts, less possibilities of things to go down. Cost goes down, better for you, better for your suppliers. You get the idea. DMAIC, is at the heart of Six Sigma. You define, you measure, you analyze, you improve, and you control. So you probably see right there the Deming cycle, right? PDCA cycle. The DMAIC is basically the Deming cycle, but improved. Employees at all levels define what needs to be done to ensure quality, then they measure, and then they analyze results using statistics to see if standards are met. They're also charged with finding ways of improving and controlling quality. Now, having said all that, the Japanese Union, I added this. The book mentioned Malcolm Baldrige, but I want to give you a little bit of background, right? So remember, Deming went to Japan after World War II, so not long after the end of World War II, 1945, right, is the end. I believe around 46, 47 is when the U.S. sent him there for the post-war census. And the Japanese were really, really open to everything he had to say, Japanese industrialists. And you know all these companies, Toyota, Honda, all these companies that you're familiar with that are Japanese companies, he was involved with them. In 1951, in recognition of all that he did, the Japanese Union of Scientists and Engineers honored Dr. Deming by creating the Deming Prize to recognize businesses worldwide for excellence in applying TQM. So that was in 51. Now, I told you what happened in the 70s and the 80s. The U.S. kind of got caught in this race with Japan, where Japan was starting to surpass the U.S. in the especially quality of its cars in the auto industry. And all of a sudden, it was catch-up time. In 85, the U.S. government created the National Medal of Technology and awarded it to Dr. Deming in 87. The same year, in 87, the Malcolm Baldrige National Quality Award was established by Congress to recognize companies that offer goods and services of world-class quality. Essentially, what I'm showing you here is that what the Japanese created in 51, named after Deming, we created something like it in 87. Just a way for you to understand the timeline of quality and how a lot of the quality programs that you learn today, Lean, all that stuff, is going to have a lot of Japanese in it. And that makes sense because a lot of it was taught back to us. So Deming went there, taught it to Japan, and then Japan taught it back to us. International Standards Organization I usually refer to it as the International Standards of Quality, right? International Language of Quality, is what I refer to it as. International Language of Quality. You're making an airplane, you're Boeing, and you want to get parts from all over the world. But what if countries, manufacturers in other parts of the world maybe have different standards than you? Well, all you got to do is make sure that you all agree on one set of standards. Congratulations, it's called ISO, based in Geneva, Switzerland. And so introduced in the 80s, by the way, again, the 80s was pivotal. The 80s was pivotal because it showed a need for some kind of standardization in the world for quality. And why is standardization so critical? Because the enemy of quality is deviance from the norm, right? So every, widget that you make, if it has to have it built within a certain, variation of alloy and size, etc., well, you can't modify the composition of the alloy or the size because that's a defect, right? So standardization is critical. And in this case, ISO 9000 was a very big deal. 5 technical standards designed to offer a uniform way of determining whether a manufacturing plant or service organization conform to sound quality procedures. Later, ISO 9000 was ISO 14000 was launched after ISO 9000. And this one deals with environmental issues such as global warming, water pollution, etc. If anybody in this class or anybody watching this has ever worked for a company that had to get ISO certified, you know exactly how difficult, how engaged, and monumental of a task it is to get that approval. Everybody remembers their first ISO audit, and it's just brutal. So this is a real robust and legitimate program. Lean manufacturing trims the fat. Lean manufacturing, if you do a Google search, very simple Google search, lean manufacturing, it will be impossible for you to not see a bunch of Japanese words, and especially to see Toyota. The Toyota production system is credited as really having launched and pioneered lean as we know it today. So lean streamlines production by getting rid of steps in the production process that don't add benefits customers want. No value-added production processes are cut so that the company can concentrate on its production operations resource. So if somebody wants to do something, you want to add a little something to your car, you think like maybe if we did it this, you would have to first prove that your modification or your cut would add value to the customers. It's not about you. It's not about cost for you. It's not about the company. It's always about value for the customers. The customer is literally at the heart of every decision making with lean. Toyota was a pioneer in developing these techniques, and today manufacturers in many countries have adopted the lean manufacturing philosophy. Another Japanese concept is just in time, JIT. Goes hand in hand with lean. It's based on the belief that materials should arrive when they're needed for production rather than being stored on site. Why is that bad? We talked about it earlier. Extra costs, and even maybe they can become obsolete faster. Inventory is a killer in the computer industry. You can't have inventory because by the time some microprocessor or anything that was manufactured last week might be already obsolete by the next month. Now, for the rest of it, I'm just going to kind of really skim over that last slide. But it's think of it in terms of the 3D printing that's out today, right? What's really cool is that what CAD/CAM did for manufacturing, etc. Now, on an individual basis, you can experience with 3D printing, right? You just put in the measures and the design that you want to do to the computer, and it prints it for you. Boom. And so in computer-aided design, computers are used to design and test new product and modify existing one. Think of it that way. This was like, again, 3D printing before it was a thing. And then with the CAM system, now the computers are used to develop and control the production process. So here, the first one is we're talking about design of new products or modifying products. But here we're talking about now the actual production process. You have to design a process that makes those products. That's CAM. And so the CAD/CAM systems combine the advantage of both, right, by integrating design, testing, and manufacturing control into one linked computer system. All right. Well, I think I was able to do this in just under an hour. I hope you found this chapter interesting, and I'll see you guys on chapter 11 next week.